Okay, we are beginning Target A, and we are doing interpreting key features of graphs and tables. So, learning goals for this lesson. I can identify how variables are related on a graph. This is not new. You should be good here. No problems. Identify the domain of a function when given a restricted range and express the solution as an inequality. We've done this, but this is actually pretty easy. You should catch on to that fairly quick. Use information provided in a real-world context to determine the domain and range. Nothing really new here, so you should be good with that. Identify the domain given specific rates of change. Shouldn't be a problem. And interpret information given in a graph to give answers in a real-world context. Should be nice and easy. So at least about half of this should be stuff that you've done before. All right, so how are the variables related on the graph? Guys, this stuff's easy. So it's always going to be as whatever x is increases, whatever y is either increases or decreases. That's all you have to say. So what's going on? Well, in this graph, since it's going up from left to right, both the x and the y are increasing. So as time, here's my x, increases, because remember, this is always increasing. The only thing that's going to change about this first sentence is this right here. This is the only thing you should ever change. The position of the object, that's this right here, that's your y, increases. So this could change. It could either be increases or decreases. And this part changes. Okay? So, the only things that change are the things that are underlined. So as whatever your x is increases, whatever your y is either increases or decreases. In this case, it's increasing because it's going up from left to right. All right, so we have to find the domain of this function with a range of y is greater than or equal to 3 but less than or equal to 7. We have to express the solution as an inequality. So basically, our domain, because we need to find the domain, is going to be in the same format as this, but because we're talking about domain, this will be an x instead of a y. So it's going to have this same format. The only two things that's going to be different is your smaller number is going to be here, your larger number is going to be here. So we start off, we're talking about range, which again is our y's. And if you forget that, there's a y right there. So when our y is between 3 and 7, we want to find out what our domain is. So all you have to do is basically go over and notice where the line intersects those spots right here and right here. This is where our line segment intersects 3 and 7. So all we have to do now is draw down and notice our x values are 3 and 9. All we do is plug in the small one, plug in the large one. Okay, it's that simple. Third one. A wedding banquet hall is capable of seating 550 guests. For each guest, the amount of money that the couple pays, which we'll call P, is a function of the number of guests, which we'll call G, in attendance. If each guest's meal costs $70, find the domain and range of this function. Well, it's a function of the number of guests. So whatever it's a function of, the number of guests, okay, G, that's what that represents our domain, or our x values. Okay, P is our y values. So since we're talking about domain, the best thing to do is basically write out what the function is. P of G equals 70, because it costs $70, per guest, G. Okay, so it's the number of guests, or per guest, $70 per guest. So if we're trying to find out what the domain is the number of guests. Well, we can't have fewer than 0 guests. We can't have negative guests. So we have to include this, must include. Okay, and then this over here, okay, this 550, where did I get this? Well, we have a cap on the number of guests we can seat. We can only seat 550 guests, no more. So G has to be less than or equal to 550. So your final answer for the domain is G is greater than or equal to 0, but less than or equal to 550. Now to find the range, all we have to do, because now we're finding this, is replace G with this number and find your answer, and then again with this number and find your answer. Okay, so if I plug in 0, I get 0. If I plug in 550, I get 38,500. So my range is written like that. P is greater than or equal to 0, but less than or equal to 38,500. Okay, for the domain, or for this graph, we need to find the domain where the interval has a positive rate of change. In other words, it is increasing from left to right, negative, and 0. So all you have to do is, where is my graph going up? Well, right in here. And if this is 1, that means that this is 2. That's 0. If it helps, number it all out. Okay, so it's a positive rate of change. Again, write it as an inequality. X is greater than or equal to 0, but less than or equal to 2. Negative rate of change is where it's going down. X is greater than or equal to 5, but less than or equal to 7. And then a 0 rate of change is where it is not moving at all, up or down. It's just going perfectly horizontal, right in there. And that's when X is greater than or equal to 2, but less than or equal to 5. Okay? Again, pretty simple stuff. And then final example. When an auto mechanic has 92 cars enter his shop during the week, the cumulative frequency graph plots the number of cars entering each day. How many cars went into the auto shop by Wednesday? Well, all you have to do is take a look at Wednesday and go up, 31. How many went in by Friday? Same thing. Go on to Friday, go up, 54. Here's the tricky one. But again, if this is a test and this is a 3-point problem, you got an easy +1 and an easy +1. You got an easy 2 points right there. That's for this last one. 60% of the cars, well, we have to find what 60% of our total is, which in this case is 92. So remember to write your percentage as a decimal. 0.60. So notice I have that here, 0.60. And 60% of 92 is 55.2. Now, on Friday, 54 cars had come in. Okay? So we don't have the 55.2 that we need, and obviously it's not going to be 0.2 because you can't have 0.2 of a car. But Friday, 54 cars were in. We had 50. We want to know when there are 55.2. Well, Saturday there are 74, which means that we're somewhere in here is what we're looking at. So we'll say by Saturday because that's the next day. Because by Friday there weren't quite enough. By Saturday there were well over that. So we'll say by Saturday because it's somewhere in here. Okay? So that's it for the first target. 3 targets to go in this particular key concept. And you guys have a lovely day. If you have any questions, please, please, please come into class and ask them. All right? Take it easy, guys.